I'm Jono, comparing PyCharm, Jupyter and Spyder to show you why most advice you've seen is completely outdated. I wrote the script and hours on the voiceover. Let's start the blueprint.
Every comparison of these three tools makes the same mistake. They line up features, count checkboxes, and declare a winner. The problem is that these are not three answers to the same question. One of them is not an editor at all. It is a document format that accidentally became the standard for an entire scientific discipline after a single $6 million grant in 2015. One of them was built as a direct copy of a layout that costs over $800 a year to license, and most of the people who have it installed do not know it is on their machine, and one of them just killed its own free version, absorbed it into a product with a subscription, and quietly made the feature that used to cost money available at no charge, which means almost every comparison video published before mid-2025 is now giving outdated advice. Jupyter was spun off from an existing interactive Python project in 2014 by a group of 7 developers. The name is not random. It combines the first letters of 3 programming languages, Julia, Python, and R, and the logo is a direct reference to Galileo's notebooks documenting his observations of Jupiter's moons. The entire philosophy is built around the idea that a scientific notebook is both a working tool and a communication artifact. The core concept is that code, its output, and written explanation belong together in the same file. You write a block of code, run it, see the result immediately below it, add a paragraph of text explaining what happened, then write the next block. The file you produce is not a script. It is a document. This is why it became the default format for academic papers, machine learning tutorials, and data science courses worldwide. By 2021, nearly 10 million of these notebook files existed on the major code hosting platform. The journal Nature named it one of 10 computing projects that transformed science. The transformation was funded by a single grant. In 2015, 2 charitable foundations gave the project $6 million. That money turned Jupyter from a niche tool into the universal standard for computational science. The file format won. Every major cloud provider now runs notebook-compatible environments. Even the company behind the paid editor in this comparison added native notebook support to its free tier because ignoring the format was no longer viable. In 2024, the project moved from its original fiscal sponsor to the Linux Foundation, which provides long-term governance and financial sustainability. The current actively developed version is the lab interface, which reached version 4.5 in late 2025, with features like cell windowing that only renders what is visible on screen, real-time collaboration, and multiple cursor support. The problems are structural and well documented. A researcher at a major artificial intelligence institute gave a talk at the Jupyter Developers Own conference in 2018 titled, "With the blunt statement that he did not like notebooks." 7 years later, the talk is still regularly cited. The core issue is hidden state. Cells can be run in any order, and the output you see on screen may not reflect what would happen if you ran the notebook fresh from top to bottom. 2 people editing the same notebook and committing to version control can produce a file that is structurally broken and cannot be opened. Every cell stores an execution count that changes every run, and every chart stores a memory address that changes every run. Standard version control tools show a wall of meaningless differences. Testing is effectively impossible. There is no built-in way to write unit tests for notebook code. Refactoring does not exist because there is no concept of a code base, only sequential cells. The classic pattern in data science is to prototype in a notebook and then spend 3 times the original development time converting it into something that can actually be deployed because notebooks cannot be directly imported, tested, or run automatically. For exploring data, presenting findings, and teaching, nothing matches it. Spyder was created by Pierre Raybaud, a French developer who released it in October 2009. The name stands for Scientific Python Development Environment. The layout is a deliberate replica of the interface used by the software it was designed to replace, which charges over $800 a year for its base license. For any scientist who learned to code in that environment, Spyder's 4-pane layout is immediately familiar. Editor on one side, console on another, help viewer in the corner, and the feature that defines the entire tool sitting permanently visible in its own dedicated panel. That feature is the Variable Explorer. While you write and run code, every variable in memory is displayed with its name, type, shape, and a preview of its content. Double-click a data array and it opens in a spreadsheet view. Double-click a table and it renders as a formatted grid. This is not something you activate through a menu or see only during debugging. It is always there, always updated, always showing you the state of your data. Neither of the other two tools in this comparison provides anything equivalent as a native, persistent feature. It is the single most cited reason scientists choose Spyder over everything else. The distribution story is unusual. Spyder is bundled with the Anaconda platform, which has roughly 50 million users across 1 million organizations. This means tens of millions of data science students have Spyder installed on their machines without ever choosing it. The catch is that the bundled version is often outdated, and the Spyder team explicitly warns that using the package manager to update it within the distribution will break the installation. The recommended path is a standalone installer or a separate environment. The result is an enormous installed base with a much smaller population actually running the current version. Funding has been fragile. In 2017, the company behind the distribution provided 4 part-time developers for about 18 months before withdrawing support. The resulting slowdown delayed the next major release by years. Current funding comes from a scientific computing initiative and a fiscal sponsor, with 2 lead maintainers and international volunteers. Version 6 arrived in September 2024 after 2 years of development, bringing a dedicated debugger panel, support for modern code formatting tools, and the ability to plot directly from the data viewer. The gaps are the gaps of a tool that knows exactly what it is and refuses to pretend otherwise. Notebook support is minimal. Version control integration is thin. Web framework support does not exist. Artificial intelligence features are behind both competitors. If your work stays within scientific Python scripts, numerical analysis, signal processing, and simulation, Spyder does that job with less overhead than either alternative. If your work moves beyond that scope, you will eventually outgrow it, and the tool is at peace with that limitation. PyCharm is made by JetBrains, a privately held company founded in Prague in 2000 with roughly 1,500 employees. It is built on the same foundation as their flagship Java editor, which means 20+ years of static analysis engineering has been applied to a language that was never designed to be analyzed statically. The result is an editor that understands your code at a level the other two tools do not attempt. When you type a method call on a data table, it knows the specific columns in that table. When you call a function with the wrong arguments, it catches the mistake before you run anything. When you rename a variable, it updates every reference across every file in the project without breaking a single import. The biggest change in 2025 is the unification. Previously, there were 2 versions. A free community edition that handled basic Python but had no notebook support, and a paid professional edition that included notebooks, web frameworks, database tools, and advanced debugging. Starting with the April 2025 release, the 2 merged into a single product. Notebook support moved into the free tier. So did integration with the cloud notebook platform used by millions of machine learning practitioners. The practical consequence is that every comparison video, blog post, and recommendation published before mid-2025 that says PyCharm requires payment for notebook support is now incorrect. What remains behind the subscription is substantial. Web framework support for the major Python server frameworks, database tooling drawn from a separate dedicated product, remote development through containers and secure connections, the full artificial intelligence assistant, which now includes a coding agent that can execute multi-step tasks autonomously, and, as of late 2025, direct integration with an external agent from an artificial intelligence company through a bring-your-own-key model. Cloud. Compute for machine learning workloads launched from within the editor. Advanced profiling and test coverage. Visualization. The cost of all that intelligence is resources. The indexing engine that makes PyCharm's code understanding possible needs memory to run. 500 megabytes or more at runtime is normal. Cold startup takes 30 to 60 seconds. On machines with 8 gigabytes of memory and other applications running, the editor can feel heavy. This appears in virtually every user review and has for years. The other 2 tools in this comparison run comfortably on hardware that PyCharm struggles with. For anyone building Python software that will be deployed, tested, or maintained by a team, PyCharm is the tool that treats those requirements as primary concerns rather than afterthoughts. The debugger is routinely cited as the best available for the language. The test runner integrates directly. The version control interface handles branching, merging, and conflict. Resolution without leaving the editor. These are the features that matter when code moves from experimentation to production, and they are the features that neither a notebook nor a scientific computing environment was designed to provide. The tool that none of these three teams built is quietly handling all of their jobs at once. The dominant general-purpose code editor can run notebooks through an extension downloaded over 40 million times. It has a variable viewer. It has a Python debugger. It has version control. It has the most widely used artificial intelligence coding assistant built in. It starts in under 2 seconds, and it is completely free. The honest question underneath this entire comparison is, what do these three give you that the general-purpose editor does not? Jupyter gives you the document. The notebook file is not just a way to write code, it is the product. The format is locked into academia, into machine learning education, into every major cloud platform. If your work needs to be shared as a living document where code, output, and explanation exist together, no extension in any other editor replicates that workflow at the same depth. Accept the version control limitations, accept the hidden state problem, and accept that anything built in a notebook will need to be rewritten before it can run in production. Spyder gives you the variable explorer. Persistent, always visible, updated in real time as you work. If you think in terms of inspecting data as you manipulate it, if your background is in the scientific computing environment that charges hundreds a year for a license, and if your work lives in standard Python scripts rather than notebooks or deployed applications, Spyder is the only tool that puts data visibility at the center of the experience, rather than behind a debug session or an output cell. Accept the small team, accept the thin version control, and accept that the tool will not grow with you if your work moves beyond scientific computing. PyCharm gives you the professional development environment. The debugger, the refactoring engine, the project-wide code intelligence, and the test integration exist because building software is a different discipline from exploring data or writing scientific scripts. The 2025 Unification means notebook support is now free, which removes the pricing objection that kept it out of recommendations for years. Accept the memory cost, accept the startup time, and accept that the depth of features comes with a learning curve that the other two tools deliberately avoid. 3 different tools for 3 different jobs. The mistake is treating the choice as permanent. The work changes, and the tool should change with it.
Every choice is a trade-off. At least now you know what you're trading.